So you want to know what a derivative is, right? Alright then, let's discuss one of the definitions, and a visualization of this concept might help before we learn any shortcuts. Now, derivatives sound very scary, they sound like a foreign thing that you don't know, but it's pretty simple and it's building off the algebra concepts we already know. So let's look at this general equation here, the definition of a derivative, okay? What if I told you it was equal to y2 minus y1 over x2 minus x1? Now that looks familiar, right? Now that is the general slope equation. Now if you knew what difference quotient is, that would look pretty similar here too. Now, this part is different, right? We don't know what this is, right? So how can we interpret this? Well, the limit basically tells us that we can approach it x approaching some value a. So it's getting closer and closer to a, right? So let's say a is equal to 2, x will be 1.99999 something, a million nines. It doesn't matter. It will be getting really close to 9, right? But it's a very important distinction that it doesn't equal 9, right? Because otherwise you would just plug in 2 or whatever you wanted, right? Because we're trying to predict the behavior. So on this graph here, what we can see is we have a point A here, right? And then x is just getting closer and closer and closer to it. And the closer we get, a better estimation we get of the slope, right? Because the slope is just, what, 2 points, right? So if I have a slope here, and I have a slope here, this is a bad example. Let me get a curve graph. If I get a slope here and a slope here, and I was from here to here, this was my a and this was my x, that wouldn't be very accurate to the slope of a, right? At the point A, if I was really close to x, I'd get a downward slope, right? And that would be a more accurate representation of the tangent line. A tangent line is just a line that touches at one point, right? Oh, yep. This is a tangent line, right? It touches a circle at one point and only one point. That is the idea of calculus, or a derivative, right? It's the instantaneous slope at a point A, and the limit is just a representation of this instantaneous slope. Pretty clever, right?